guys, hopefully you did well on your test from Chapter 6. We're going to jump right into Chapter 7 tonight, so I want you to open up your books to page 427, get out your notebooks, and we're going to start talking about something brand new to you, system of equations. I want to first of all refer you to our essential question, which is how can I solve for two equations at one time? And not only are we going to be solving for two equations at one time, but we're going to be solving for two equations that have the same x and y value for a solution. Now there's three different ways that we can solve, which is graphing, substitution, and elimination. However, today we're going to focus on graphing two equations at one time. Now graphing equations is not anything new to you. We spent quite a bit on this during our first semester. And of course, that's just identifying your slope and your y-intercept and then simply plotting the equation. Now of course we only plotted one at a time. Here we're going to be plotting two. So let's just jump right in and get started. We're actually looking at the example on page 421, example 1, but I am working it a little different, so really tune in. One thing I like to do when solving these is to go ahead and put both equations in the slope-intercept form, identify your slope and your y-intercept, and then graph them. I just think it's easier for you to be able to practice that. Okay, so let's look at our two equations. We have equation 1, which is x plus 2y equals 7, and equation 2, which is 3x minus 2y equals 5. Now what I want to do is I want to identify the x value and the y value that will satisfy both equations. These two values will be the same value, okay? So, first thing I'm going to do is I'm going to take equation 1 and put it into slope-intercept form. And I'm going to do that simply by subtracting x from both sides, which we did here in step 2. And then we're going to divide both sides by 2 so we can get y by itself. So our end result is x equals negative 1/2 x plus 3.5. Okay? So these are simply my steps. The next thing I'm going to do is identify my slope and y-intercept. Of course, the slope is always the value with the x, not the x, the value of the x. And that's negative 1/2. And my y-intercept is 3.5. Now, we're going to come over here and we're going to look at this graph right here, this line. If you will notice, my y-intercept is at 123.5, and my slope is negative 1/2. So we go down 1/2 over 1, plot the point. Okay? Down 1/2 over 1, and plot the point. I don't know why I have that extra point there. We'll take it off. All right, and then draw your line through it. That simple. Now we're going to take equation 2. 3x minus 2y equals 5. Subtract your 3x from both sides so that we have negative 2y equals negative 3x plus 5. Then you're going to divide everything by negative 2. So we'll cancel here, and we're going to have negative 3 over negative 2x plus 5 over negative 2. Of course, negative by negative will make a positive, and 3 over 2 equals 1.5. And then 5 over negative 2 will make a negative, and that equals negative 2.5. Notice how I'm putting these in decimals, and the reason why is so that it makes it easier to graph. Okay, so I'm going to identify my slope, which is 1.5, and my y-intercept, which is negative 2.5. So we're going to go to 1.5, or excuse me, negative 2.5 on our y-axis, 1, 2, 2.5, and then our slope is 1/2. So I'm going to go up 1/2, 1 over 1, up 1/2, 1 and over 1, and then once again. And then you will see here that the two graphs are actually crossing at 3, I'm sorry, I didn't erase from our last problem, 3 on the x-axis and 2 on the y-axis. So that is going to be the solution for both equations. Now, let's test this out and see if it works. Let's take equation 1, which is x, so we're going to put in 3, plus 2y, 2 times 2 is 4, equals 7. Okay, that works. Let's take equation 2, which is 3 times 3, which is 9, minus 2 times 2, which is 4, equals 5. And we see it works for both equations. So good deal. Okay, now we're going to talk about types of linear systems. Okay, first of all, when we have exactly one solution to our linear system, such as here, 3 and 2. We call that consistent. We say that it is a consistent, independent system. Okay, look at the top of page 428. In our key concept box, it says our steps for solving a linear system. Graph both equations in the same coordinate plane. We did that. For the ease of graphing, you may want to write the equations into slope-intercept form, which is what we did right here and right here. We found the slope-intercept form. Estimate the coordinates of the point's intersection. And that's what we did here. Now, using graph paper is going to be very important. So you're going to need to use your graph paper. And then step 3, check the coordinates algebraically. And that's what we did. We just substituted into 2 and 3 for the x and y values in both equations in order to solve. Now, we're going to go ahead and look at example 2 on page